Cool. Thanks, Phoebes. Yeah, so good morning, everyone. My name is Darcy Watchorn. I'm a PhD student from Deakin University. As you can see, I'm not Phoebe Burns, but I woke up this morning with no electricity or internet at my place, so I had to scramble over to her place. So anyway, yeah, today I'm giving my talk from work that I've done as part of my PhD on the use of artificial refuges by small vertebrates after prescribed fire. I'm giving this talk today from Bunurong country, and most of the research has been done in Wotherong country, but also some on Eastern Mark country. Okay, let's keep going. So first I'll talk a little bit about the interactions between cats, foxes and fire. So we all know just how devastating feral cats and foxes have been. They've contributed to the decline and extinction of dozens of small mammals across the country. And fire is a really important ecological disturbance across much of Australia, but it often results in the temporary resource depletion for many animals. So you lose resources like food and dens and of course shelter from predators. And there's growing evidence suggesting that cat and fox activity may be increased in some burnt landscapes, likely because their hunting success is improved due to the simplified habitat. So it's easier for cats and foxes to see and catch small prey. So, sorry, just let me, there we go. So what can we do about this potentially significant management problem? So some of the most common actions include lethal control, of course, such as trapping and poison baiting. And these techniques can be effective, but successful outcomes can be really difficult to achieve in open environments, and especially for cats. And then another option, of course, is prescribed burning. So that preserves unburnt natural refuges within the burn scar. And these can be gullies or swamps or just unburnt patches. However, severe wildfire can, of course, totally remove these from the environment and leave very few unburnt patches. So another potential option, which I found are being suggested more frequently, are artificial refuges. So the thinking is that providing artificial refuges in a burnt landscape may improve the persistence of small mammals by providing them with a place to forage and take refuge from predators until the vegetation recovers again and provides those resources that it did before the fire. So just quickly, what are artificial refuges? They're typically a purpose-built human-made substitute for a natural refuge that is in short supply in a disturbed or modified environment. And they generally aim to conserve wildlife in one way or another. And they provide places for wildlife to breed, to hibernate, or take shelter in lieu of those natural refuges. And they're now used all around the world for a variety of fauna. So as you can see on the slide, we have artificial rocky crevices for mobile and sessile marine fauna on a seawall in Sydney Harbour. We have artificial rocks used for this broad-headed snake, because people like to steal their rocks and use them in landscaping. And then of course we have artificial tree hollows, which are used for possums and bats and birds and all kinds of things all around the world. This nest box is installed for possums. And so artificial refuges, especially nest boxes, are quite commonly used now, but many designs are not subject to the appropriate rigorous testing to determine their efficacy before they're used. And this is sort of a really important thing to do. So well-designed artificial refuges can help achieve really positive conservation outcomes, but some can be completely ineffective and even produce a negative outcome, like an ecological trap. And as I'm sure many of you are aware, they can also be used to greenwash environmentally destructive projects or delay appropriate action to address the underlying cause of decline. So as part of my PhD, I've co-authored a couple of articles now on artificial refuges and their role in wildlife conservation, be it positive, negative, or neutral. And yeah, I'm always happy to chat more about them if anybody wants. So what do my artificial refuges look like? They're 50-metre long tunnels made from chicken wire and shade cloth so only small animals can enter. And the idea is that they can enter and exit them from any point, so along the sides of the tunnel as well. In that sense, tunnel isn't really the most appropriate name. And anyway, so hopefully that the behaviour isn't predictable to predators, because yeah, they can enter and exit from anywhere. And many of you might have seen these out in the field or photos of them before. There was Gemma showed a photo of them earlier in her talk. So at each treatment site, we built 5 tunnels, and just within a couple of weeks of the prescribed fire, they ran parallel downslope and were spaced about 10 to 15 metres apart. And the sites were located in heathy woodland behind Aries Inlet and Anglesey, and also Jellybrand, after prescribed burns in 2019, 2020 and 2021. And so I'm conducting several experiments to investigate how prey species respond to the provision of these artificial refuges as part of my PhD. And today I'll be discussing the preliminary results from 2 of these experiments. And so hopefully we can answer the following questions: do small vertebrates, so birds, mammals and reptiles, use the artificial refuges? And do they improve the persistence of small mammals, so at the population level? So first, let's explore that first question. So which small vertebrates did we find using the artificial refuges? So for this experiment, I had 8 sites that were burnt by prescribed burns, and we built 5 refuge tunnels at each site, as I mentioned. And to see which animals use them, we deployed 10 camera traps at each site. So 5 of them were placed in the middle of the tunnels, and 5 of them just outside, so 7 or 8 metres outside the tunnel, in sort of similarly burnt habitat, just not inside a tunnel. And the cameras were set up shortly after the fire and recorded activity for about 12 months. The cameras were infrared, and importantly, they weren't baited. And onto some preliminary results. So here's a brief overview of some generalized linear mixed models for a couple of the interesting species groups. So for reptiles, and this is all reptiles we detected, so skinks, and mostly skinks, but also a few snakes, white-browed scrub wrens, and all small mammals. The trend is that the number of detections, which you can see on the y-axis, both inside and outside the tunnels, are increasing with time since fire, which is on the x-axis, so from 2 weeks to 50 weeks post-fire. And you can see that the number of detections were much higher inside the tunnels for white-browed scrub wrens and for reptiles, but there was no real difference for small mammals. So we detected plenty of small mammals inside the tunnels, but pretty much just as many outside the tunnels. So small mammals didn't appear to be using the tunnels more than nearby exposed areas. So let's explore the second question: do artificial refuges actually improve the persistence of small mammals? We do know that at least they are inside the tunnels from time to time. So for this experiment, we had 20 sites in total, 5 of which were unburnt controls, so sites which were not burnt at all. We had 8 burnt controls that had no refuges, and then we had 7 treatment sites with the artificial refuge tunnels installed. And we conducted alliot trapping at each site across 5 survey periods. So at 6 to 12 months pre-fire, and then again at 2 to 3 months pre-fire. And then we had 3 post-fire survey sessions at 2 weeks post-fire, 6 months post-fire, and then at 11 months post-fire. The artificial refuges were installed immediately following the 2 weeks post-fire survey. And the 2 most commonly captured species, sort of somewhat unsurprisingly, are the agile antechinus and the bushrat, and animal numbers were generally quite low throughout the region at all of the sites. Just some preliminary results now for the bushrat. So you can kind of see before the fire, there were a few more animals at the sites that would go on to be the burnt control, so the bluey purple colour there. There weren't many rats at all at the treatment sites before the fire. And then after the fire, there were more animals at the unburnt sites and very few at the burnt sites with or without the artificial refuges. In fact, we caught no rats whatsoever 11 months post-fire. For the agile antechinus, there were a similar number of animals at all 3 site types before the fire, and a few less animals at the burnt control sites immediately after the fire, although the refuges sort of had not yet been built. They were built immediately after that survey. And the number of animals were similar across the 3 site types at 6 and 11 months post-fire. So I will just note that I've been intermitting from my PhD for the last several months now. And in fact, I stepped away as soon as I finished the fieldwork for this chapter. So I haven't yet had time to analyse the data thoroughly or really do anything that resembles sophisticated modelling or incorporate site-specific variables. So this is pretty much just a summary of the raw data. So that's why it's sort of so simplistic. But whilst the results are simplistic, they do suggest that the tunnels did not improve the persistence of bush rats or our giles considerably after the fires. But I'll discuss this in a bit more detail in the next slide. So just a brief summary of our first question now. So which small vertebrates use the artificial refuges? So we found that a range of bird, mammal and reptile species interacted with the tunnels, and the detection rates of small mammals were similar inside compared to outside. However, the detections of skinks, white-browed scrub wrens, and other species which I didn't show, like the superb fairy wren and painted button quail, were considerably higher inside the tunnel relative to outside. Importantly, though, we did not measure the population response of these species to the tunnels, so we can't say whether they improved the persistence of these animals post-fire. We just know that they seem to really like to use them, which is a good sign. Now, a brief summary of the second question. Did artificial refuges improve the persistence of small mammals? So we probably didn't find strong evidence that suggests that the tunnels did improve persistence. Perhaps the artificial refuge tunnels here may not be appropriate tools then for conserving small mammals from the potentially elevated risk of predation following fire. Although I'll emphasise again that the data is very preliminary and the results may change with further analyses. Come back next year and I'll give you the lowdown. But it's quite possible that the outcome of this experiment will vary due, of course, to fire severity. So the prescribed burns that we used in this experiment were very patchy. They were great ecological burns, but this may reduce the impact or the potential benefit that sites with the artificial refuges may have compared to a large and severe wildfire. It may also be that this design does not cover a large enough area to suitably reduce the risk of predation, because both antechinus and bush rats move and forage quite a lot each night. They cover a fair bit of ground. And then finally, the small mammal numbers in our study area, which was predominantly the eastern Otway ranges around Aries and Anglesea, have plummeted in recent decades. And generally, there are very few animals at all of our study sites, including the unburnt areas. And so this likely made it quite difficult to detect a population level response. And of course, the impact of sort of any predation event is really elevated in small populations like these. And so localized absences of small mammals at our treatment sites could still likely occur even with reduced hunting success for cats and foxes. So like all good PhD projects, these experiments have probably raised more questions than they've answered. I certainly recommend further research on this and different artificial refuge designs, ecosystem types, and faunal communities as well. And I think conducting a really similar experiment to this one in an ecosystem with slightly healthier and more abundant small mammal community following a more intense prescribed burn, more severe, might be particularly beneficial in untangling some of the threads that I presented today. So that is all from me. I'd like to quickly thank my project contributors, of course my supervisors, Barbara Wilson, Mark Arkarklis, Don Driscoll and Tim Doherty, the numerous project partners that have provided financial support to the project, the many volunteers who have helped along the way, and of course the generous support from DELP, Parks Victoria, the Forest Fire Management staff, who've been very valuable. So thank you very much.
Thanks, Darcy. We're running a little tight on time, but I'll ask one of the questions. Do you think that the artificial refuge tunnels pose a risk to trapping due to potential chicken wire entanglement?
I guess I wouldn't say it's not impossible. If something were to happen to alter the structure of the tunnels, maybe a branch would fall on them and alter the tunnels in such a way that there were maybe exposed edges that a larger animal could try and squeeze through, then it's possible. Animals do get stuck in fences from time to time. It's not something that we've observed, but it's possible.
Thanks, mate. There's a few good questions in the Q&A section. If you wouldn't mind having a crack at answering, that'd be great, especially one from George around whether or not we should be burning some of the wetter forest types.